Today I wanted to do a reaction video about Arvin Ash's video, Is the Universe Fine-Tuned for Life? And he tried to pretend that it's not a religious argument, but when you say something's fine-tuned, that requires a fine-tuner, and any being that can violate the laws of physics in order to rewrite them is, by definition, a god, at least a definition I like. Beings that can't alter the natural laws of physics are ordinary beings like humans. But I don't want to turn this into a God versus science video, because the important thing is as scientists we can learn how the physical constants emerge and understand. And by understanding, we know that this isn't even a rational question to ask. Now, this is a subject I've studied quite a bit. I did a chapter in my book, God Hates Science, which is debunking of 50 or so different proofs of the existence of a God. And I decided to take the approach of showing how the constants developed, rather than just saying, oh, it's a nonsensical argument. We can be scientific about it. And I went on to present a paper at a conference in 2019 in Prague. I'll try to link that video below if you want to watch the whole hour-long video. And then I also wrote several papers that I'll also try to link below that talk about how the constants evolved from the quantum field. And with that, I'll go ahead and let him give his introduction.
Physics is full of constants. These are values or properties for which there's no theoretical basis. They're only determined by measuring them. Some of these constants are things like the charge of the electron, the gravitational constant, Planck's constant, and many others. If any of these numbers were different, our universe as we know it would not be the same. And we probably would not be here if that was the case. Why do these numbers have the values that they do? For that matter, why are we here? This is the core of the fine-tuning argument. It goes something like this. The constants of nature are statistically improbable. These constants are on a razor's edge, such that even a slight deviation would likely result in no life as we know it in the universe. Some take the argument further and say that this fine-tuning is so unlikely that it could not have occurred by pure chance, that there must be some agent that set up the constants to enable life. There are others that reject this argument for various reasons, but the discussion of fine-tuning is a very important existential question. In this video, I'll take a look at both sides of the picture and give you what I think are compelling arguments both for and against the fine-tuning of the universe, so that you can be well informed enough to make your own judgment. And that's coming up right now.
As you can see from the comments, I'm not very happy with the way he introduced the topic, because as scientists we can take a scientific approach to understanding how the physical constants emerge and how they evolve. And to begin with, Robert Dicke, an American physicist, realized in the 1950s that because the quantum field produces electric and magnetic fields, that it has to be polarizable. And if it's polarizable, then the electric constant, magnetic constant, the permittivity and permeability are emergent properties. They emerge from the field. And from that, you get the speed of light, because the speed of light is a function of those constants. And then the impedance of the quantum field and the admittance of the quantum field are also functions, as I show in the equations. And beyond that, Dicke realized that the wavelengths and frequencies are due to the quantum field, their emergent properties, which means dimensions and clock rates are emergent properties of the quantum field. They're not emergent properties of space. And because of that, he developed an idea about general relativity being electromagnetic phenomena. Now, it wasn't new. Einstein actually started working on that in 1907 and then unfortunately abandoned it, or else we would have unified general relativity with quantum field theory back around 1910. But what Dicke did was very important. Then the next equation, which is very important when you're looking at constants, is the fine structure constant alpha is equal to terms involving the permittivity or permeability, it can be written in either way, and the speed of light, the fine structure constant, the electric charge squared, and you also have Planck's constant in there. So you have 5 of the most important constants, 6 if you include the permeability, and you can use h bar or h for Planck's or reduce Planck's constant. So you put a whole bunch of constants together, and they can't vary independently except in very limited ways in relativity theory. Now we already know that permittivity and permeability and the speed of light are related to the polarizability of the quantum field. If we look at the Gauss's equation for the electric charge, it says that a single electric charge produces a polarized field on a surface. Well, what I realize is we've been looking at this backwards. Instead of the polarized flux that we measure along a surface, the polarizability of space is the limiting factor, and that's determined by the quantum field. It's the polarizability of the quantum field, not space. And the polarizability of the quantum field determines the ultimate charge of an individual polarizer. So a particle only has to act like an electron, only has to act like a polarizer, and the field determines its charge. So it's a quantum field property. And then h, Planck's constant, is a scaling factor to energy. So we can set it to 1 in what's called natural units. And in natural units, that effectively means that one wave is the energy unit. One cycle of a wave, such as a photon, is an energy unit. And that's the simplest way to look at these constants. And when you do that in natural units, the fine structure constant alpha is equal to E squared, the charge squared, divided by 2. Which, if you've ever taken any basic calculus, you realize that that's the integral of E. So that tells us that the fine structure constant is actually a way of looking at the volumetric polarization space. E looks at the surface, alpha looks at the volume. And they're both due to the polarizability. So all the constants in the second equation that I list for alpha are based on the polarizability of the quantum field. And then we can look at the mass. If you look at a proton mass, the proton has a shell of quantum fluctuations, and the quantum fluctuations do the scattering that gives us the charge radius that we measure. If you look at what that shell, how much quantum energy, quantum fluctuation energy, or 0-point energy it excludes, it equals the mass of the proton. And if you use the equation I show, where you need to know the diameter, effectively, inner and outer diameters of the shell, it has Planck's constant and the speed of light in there. Those are the only two constants, which are related to the polarizability of the quantum field. So that means that mass is electromagnetic. So in addition to the proton, the electron's the same way if you assume it has a shell at the Compton wavelength, the electron Compton wavelength. And a neutron also can be treated as a shell, and the mass determined that way. And then we also know that there's quantization of the masses of all the heavier particles, and they're quantized at the mass of the electron divided by fine structure constant. And the Higgs is the mass of the proton divided by the fine structure constant. So all the heavier masses are electromagnetic, as well as the basic masses of the proton, electron, and neutron. And after that, the Bohr radius is a function of constants that are due to the polarizability of the quantum field. The Bohr magnetron, which is the magnetic moment of the electron or related to it, the magnetic moment of the electron itself, the nuclear magneton, and the magnetic moment of the proton and neutron are also related. So all the magnetic constants of the particles ultimately arise from that. Then we can also look at something like the strong force, which I've shown if you calculate the Casimir effect between two spheres, and I put the equation up there, that gives you the energy and range of the strong force. And it's a pretty simple equation. Once again, it has Planck's constant, the speed of light, and you get your answer. So it's electromagnetic. And of course, the weak force is electromagnetic. That's been known for a while, although not in the proper sense. And then gravity. If mass is electromagnetic, gravity is electromagnetic as well. And the details of that are a little much for this video, so you can look at some of my other videos. I'll try to link some descriptions on that. So all of that tells us that we have interrelations between the constants. You basically can't solve any of them independently, and none of them can vary independently. And then we include relativity, and in relativity, the permeability and permittivity, the speed of light, and the clock rates all change, which means that some of the constants change. And in a black hole, for example, they could change by a very wide margin. They can change over a very large range. And so while there's other constants that don't change at all, they're actually fixed. They don't vary relativistically. When you add that all together, there's only one unique solution of constants that's able to handle all of that. And anyone who reads through a freshman physics text and looks at all the constants listed in that text should be able to come to that conclusion. And with that, I'll give another part of Arvin Ash's video. I skip over a 5.5-minute section of speculation of what would happen if the constants were different, because they can't be different. And I go to the section where he's actually supposed to be defending the scientific method, but not doing a very good job. So here that is.
But is there another side to this coin? Just like everything in life, there are always two sides to every story. So what are the Condor arguments? In general, while the universe appears to have constants that need to be within a very precise range, such that even slight variations could result in a different universe, it does not follow that this is unnatural. There would be no basis to make that judgment, because unnatural would mean that other constants could or should exist naturally. That is not the case. There is no alternative existence in nature that we can conceive of in which nature would have different constants. And we've never measured any alternatives to these constants. We can't even say that it's improbable, because probability indicates how likely an event is to occur. But this presumes that more than one event could occur. When it comes to this universe and the constants that it has, this may not be a valid presumption. We would need to assume that other universes with other constants were possible. We don't know whether that is the case. And if it was the case that other universes with other constants could occur, then there could have been or could be an infinitely many universes with all combinations of constants. In that scenario, it would be inevitable that a universe with our constants would be among them. Statistics can't be done with one sample. There are lots of things that could be statistically improbable or impossible, such as the chances of flipping a coin and getting heads 50 times in a row. This is about 1 in 1 quadrillion. I can calculate the probability of that because getting a heads or tails are both possible, and I know the probability of each. No probability based on statistics can be calculated for the different constants of nature. But these are philosophical arguments. Are there any scientific ones?
Well, as my comments show, he's not doing a really good job of defending the scientific method and not really addressing the question of how did the constants emerge. He went on to use some examples like masses of particles as something that might support the standard model and support the scientific interpretation, and he does a bad job with that too. So we come down to there's a series of facts that we need to look at, and not all scientists are aware of this. The physical constants are emergent properties of the quantum field. They are all mathematically constrained by the other constants. The equations must hold in all sets of units, including natural units, and the equations must hold in special and general relativity. Some constants are relativistic invariant, while others vary relativistically, such as permittivity, permeability, the speed of light, and any constant involving the clock rate. The constants form a unique set. There's only one set. It can't be altered. No God or man can alter the constants. Sure, we can change the units and change the constants appropriately, but the interrelationship between the constants cannot be altered. So fine-tuning is impossible. Even if there were a fine-tuner, and you're allowed to believe in one, that's not for me to say, although don't force your beliefs on others, please. Fine-tuning is just not possible, even if there were a fine-tuner. And with that, I'll let you see Arvin Ash's concluding statement.
If the universe was fine-tuned for life, why doesn't life play a central role in the universe? Why isn't it everywhere? Why is most of the universe hostile towards life? We could not exist, for example, in space or any other planet without life-saving technologies. Even if the universe is fine-tuned, it does not necessarily mean that there's an agent that created it. If an agent such as a God created life, presumably this agent would be outside the bounds of physics that he created in this universe. If that is the case, why must there be fine-tuning in the first place? This agent can do whatever the heck he wants. If he wants there to be life, he can create life in a totally chaotic universe. Why is he bound by fine-tuning? He could create life in a universe that had a lot of slop, where the constants could vary a lot. He could create life if the mass of the electron was as much as my house. The agent is not bounded by any of the laws of physics because he would have created those laws to begin with. So it may not follow that an agent exists, even if there is fine-tuning. The precise reasons why the masses are what they are and the constants are what they are is an open question, though. We can only speculate at this point, but one of the main things we should keep in mind is that our understanding of the universe is incomplete, and we know it's incomplete. We can't explain dark matter, dark energy, the asymmetry of matter versus antimatter, and a host of other things. It's quite possible that a future more complete theory that may extend the standard model and perhaps incorporate a quantum theory of gravity could not only answer these questions, but also explain the theoretical bases for the constants being what they are. We saw a similar breakthrough with the electroweak theory, which united the weak force and electromagnetism. It showed that when we go to higher energies, two seemingly unrelated forces, electromagnetism and the weak force, unite, giving us a deeper understanding of the universe.
And again, you can see, based on my comments, that he really is pleading for the God answer. And like I said, that's not for me to say, that's for you to say, for your individual taste. But what I want to say is, as I've shown, the physical constants are emergent properties of the quantum field, and they can't be altered. So I hope you enjoyed this video. I hope you learned something I think is very important and not talked about enough in the scientific community. So if you do like this, please like it. Be sure to share it with your scientifically minded friends and subscribe for my next videos. I'm up to 500 subscribers, so thank you very much for everyone. Still hoping to reach 1,000, maybe sometime early next year. And so thanks for subscribing. If you'd like to learn more, like I said, I'll link to some of the papers, and I discuss this in my book, God Hates Science. And then I also have my other books on quantum field theory and particle theory, where I discuss the particle mass and things are discussed in those as well. So you can learn a lot more by studying my books, and that also helps me out of my retirement. So thanks for watching.